Hey everyone, welcome to Oxford Tutoring. I hope you're having a great day. Today we are doing question 29 from your chapter 4 short answers section. Right, so this is the last question in the short answer section, and of course it is a difficult one, so that's why I want to go through it today. So let's get into the question. Question 29. A complex number z satisfies the inequality, so given by this equation right here, and then we want to, part A, sketch the corresponding region representing all possible values of z. So if you want to sketch a graph, you need to find the Cartesian equation. This isn't a Cartesian equation yet. The reason why is you have a z and you still have your imaginary number. A Cartesian equation can only have x and y as its variables, okay? So if you want to sketch the graph, we need to find the Cartesian equation, and if you want to do that, as you all know, you let z equals x plus y every time. And you just replace the z right here with this x plus yi. Okay, so x plus yi plus 2 minus 2 root 3i under the mod less than 2. And then you group the real coefficients, the real terms together, and the imaginary terms together, y minus 2 root 3i under the mod less than 2. If you want to find the Cartesian equation, you can't have this mod right here. To get rid of that, there's another way of writing mod, and that is the square root, right? Remember that? So you square root and you square the real coefficient and you square the imaginary coefficient as well, okay? Do not square the I, because we only square the coefficient to find the mod. It's still less than 2, and then your equation at the end of the day is x plus 2 square plus y minus 2 root 3 square less than 4, because we're squaring both sides to get rid of the square root. And what you end up with is a circle, because that's your format. So x minus h squared plus y minus k squared equals to r squared. And your center of the circle is negative 2 to root 3. So slightly bigger on the y coordinate. And then your radius is 2, okay? So square root of 4, that gives us a radius of 2. Now, we need to sketch the region. I'll try my best to sketch the region for you. Whoops. Get the axes. Right there, so x-axis, y-axis. From experience, you'll later know that, yes, my center is negative 2 to root 3, radius is 2, so it really wouldn't go to this quadrant or the bottom quadrant, right? So let's get the center first, negative 2, right here, and then 2 root 3 may be slightly higher, 2 root 3 somewhere here possibly, and then get your circle. So I'll quickly draw a circle here that has a radius of 2, so that's 2 plus 2 root 3. These are coordinates, and that should be negative 4, and then it reaches somewhere here, 2 root 3 minus 2, right, which is still bigger than 0. Okay, connect the dots together and you get a circle. So that is our circle. A little bit skewed like a potato, but it's okay. As long as you label your points, and everything, should be fine. And as long as it looks remotely similar, close enough to a circle, it should be okay as well. And it's less than 4, or there's the inequality sign here, which is less than equals 2, so you have to shade in regions, and the region we want to shade in is the entire thing inside the circle, okay? And that includes all these lines as well. So not a dotted line, just solid line, because it's equal to, it has the equal to sign. Okay, so that is part A, guys. Nothing too complicated really, as long as you know how to sketch a circle and you know this format, how to do this algebra, you'll be fine. Okay, part B. What does part B say? Find the least possible value of mod of z. Now, what is mod of z? So we know that z is any point on this circle, right? So that can be z, that can be z. This can also be z on, as long as on the circle, okay? Now we want the least possible value of mod z. Mod z means distance from the origin, so from 0, 0 here, to the circle, so that the distance is the smallest as it can be. And in this case, if you look at this circle, it's pretty clear that if I was to connect the center to the origin right here, if I connect to the center, then this point right here would be the shortest distance. So if I go from the origin to that point, it will be the shortest distance. And if you want to find the shortest distance, what you actually can do is we can draw some triangles up, okay? So if you draw this triangle right here, so this triangle, and yep, that triangle, we know the length is 2, we know the height is 2 root 3. You can find the hypotenuse, and after you find the hypotenuse, you can minus the radius to get this distance, okay? So let's go through that first. if you want to find the hypotenuse, so I'll call that maybe, let's see, hypotenuse length, just call it L for now, okay? So if you want to find L, that is square root of 2, so we're just using Pythag, this is a 90-degree triangle, 2 root 3 square plus 2 square under the square root, and what you end up with is 12 plus 4, and that is root of 16, which is 4. So the length of this hypotenuse right here from the center to the origin is 4, but we only want this point, from that point to the center. So in that case, you go 4 minus the radius of the circle, which happens to be 2. So the minimum distance, Z min, would be 4 minus 2, and that is equals to 2, okay? So nothing too difficult for part BI. As long as you can see this triangle, you'll be absolutely fine. Okay, now BII is a little bit trickier, okay? Now, what does BII say? BII says, find the greatest possible value of arc Z. Now, what does arc of Z mean? Arc of Z is the angle you draw from, so you get from the positive x-axis, and if you get the incline, so you draw a line to any point on this circle, you want to find the greatest, the biggest possible angle you can get. And it's quite clear that the biggest angle you can get is you go, so it always starts from the positive x-axis. You go here, that's 90 degrees, but you can keep going because, you know, if you draw a line to here, that's higher than 90 degrees. So you keep going, keep going, keep going, and then you'll end up at a point where if you were to draw, so I'll do this carefully, a tangent from the origin to the circle. So if I draw a tangent from the origin to this point, so on the circle, you will get a point on over here, so that it gives you the biggest angle. So I'll draw this clearly. So this is our angle right here. That's arc of Z. We don't know what that is, but we can find it. Arc of Z, get the angle up. Okay, the triangle. So I'm going to connect this to the center of the circle. So it's very hard to visualize this. That's why this is a very difficult question, okay? So I'm going to get the triangle right here. And then that's going to connect. So that's actually the same length. So that's 4. I'm just trying my best. Whoa. Okay, that's 90 degrees because that's a tangent, okay? 90 degrees, and then we do the same thing over here on this triangle as well. 90 degrees, you'll see why, but we do need that, okay? That's 90 degrees as well. I am terrible, I'm sorry for all this mess, but as long as you can see the two triangles, you'll be fine, okay? Right, 90 degrees, that's also 90 degrees. This length is 4, the radius is 2. So you can already tell that these two triangles are similar. They're actually the same triangle, okay? So congruent triangles. Okay, that means these two angles are the same as well. These two angles are the same. Shade them in. The green angles are the same angles, okay? So these angles, same angle because they're congruent triangles. Right, if you want to find the largest value of arc Z, then we go from the positive x-axis all the way until this line, okay? If you want to find that, we know it's 90 degrees plus these two angles, or 2 multiplied by one of them. Right, how would you find one of these angles? Well, it's not too complicated. We know, so actually maybe I'll do part II here so you can see this shape as this picture as well. Right, this, so that you can see this diagram as well. Okay. If you want to find this green angle right here, so we know the length. So I'll draw this triangle, mini triangle. So I'm just replicating the bottom side. This is 2, this is 4, okay? That whole length is 4, the hypotenuse, and that's 2, that's the radius. We want to find this angle. Well, it's very clear. If you want to find that angle, it would be sine theta equals to 2 opposite over hypotenuse, which is 4. So sine theta equals to half. And as we know, theta would then be pi on 6, okay? So one green angle is pi on 6, so the other one has to also be pi on 6 because they're congruent triangles, they have the same angles then. And if you want to find the entire argument, so the entire angle, that would be pi on 2, 90 degrees, so this section right here, plus pi on 6 plus pi on 6. And what you end up with, guys, is denominator 6, so that would be 5 pi on 6. So that is the largest argument of z, largest possible value of arc z that you can get, okay? It's all about seeing triangles. That's why complex number and trigonometry are they're really interrelated, okay? Right, so that is pretty much what I want to show you guys for question 29. Hopefully you found it useful. But aside from that guys, thanks for watching and I'll see you in the next video.